Hello and welcome back. Today we'll be doing question 2 from the 2011 math paper. This is a question about polynomials. Question 2. For all applicants. Suppose that x satisfies the equation x cubed is equal to 2x plus 1. Part 1. Show that x to the 4 is x plus 2x squared and x to the 5 is 2 plus 4x plus x squared. Part 2. For every integer k is greater than or equal to 0, we can uniquely write x to the k is equal to ak plus bkx plus ckx squared, where ak, bk and ck are integers. So in part 1 it was shown that a4 is equal to 0, b4 is equal to 1, c4 is equal to 2, and a5 is equal to 2, b5 is equal to 4, c5 is equal to 1. Show that ak plus 1 is equal to ck, bk plus 1 is equal to ak plus 2ck, and ck plus 1 is equal to bk. Part 3. Let dk equal ak plus ck take away bk. Show that dk plus 1 is equal to negative dk, and hence that ak plus ck is equal to bk plus negative 1 all to the power of k. Part 4. Let fk equal ak plus 1 plus ck plus 1. Show that fk plus fk plus 1 is equal to fk plus 2. Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started with part 1. Firstly, we'll calculate x to the 4, which is equal to x cubed multiplied by x. This should be equal to 2x squared plus x. Now we can calculate x to the 5 by taking x to the 4 multiplied by x, and this gives 2x cubed plus x squared. However, we already have an expression for x cubed, that is 2x plus 1, and therefore we can substitute this in to get that x to the 5 is x squared plus 4x plus 2, as required. Now we can move on to part 2. Firstly, we'll write x is equal to k. Firstly, we'll write that x to the k plus 1 is equal to xk multiplied by x, and therefore that is equal to akx plus bkx squared plus ckx cubed. Substituting 2x plus 1 for x cubed, we have that this expression is equal to ck plus x of ak plus 2ck plus bk x cubed, and this we will set equal to ak plus 1, bk plus 1x plus ck plus 1x squared, and therefore we have that ak plus 1 is equal to ck, bk plus 1 is equal to ak plus 2ck, and ck plus 1 is equal to bk. Now we'll move on to part 3. Here, we'll write dk plus 1 is equal to ak plus 1 plus ck plus 1 take away bk plus 1. Substituting these for the values calculated in part 2, we have that dk plus 1 is equal to ck plus bk take away ak take away 2ck, and this is naturally equal to negative dk. We also have the case 1 equals 1 plus 0x plus 0x squared, and therefore a0 is equal to 1, b0 is equal to 0, c0 is equal to 0, and d0 is equal to 1. From this, we have that dk is equal to negative 1 to the k, and therefore we have that ak plus ck is equal to bk plus negative 1 to the k. Finally, we can move on to part 4. Here we have fk plus fk plus 1 is equal to ak plus 1 plus ck plus 1 plus ak plus 2 plus ck plus 2. And this is equal to bk plus 1 plus bk plus 2. However, from part 2, we have that this is also equal to ck plus 2 plus ck plus 3, and ck plus 2 is equal to ak plus 3. Therefore, this expression boils down to fk plus 2 as required. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.